Hello. That's quite the reunion you have there.
What's that?
That's quite the reunion you have going.
Oh.
If that's JT, hello.
Yes, it is.
This Meet BSD 2025. Like, wait, what?
Is there going to be such a thing?
Ask the people present. I don't know. I know nothing.
think Dexter just volunteered. That's what I heard.
PDX BSD Con. Yeah.
We'll see how this first one goes.
Yes, sir.
I guess we're a few minutes early.
One.
Hello, everyone, and welcome to the September 2024 OpenZFS Leadership Meeting. Okay, so first on the agenda, Matt wanted to be here but wasn't able to make it. But he wanted to remind everybody that you need to submit your talk ideas for the OpenZFS Developer Summit by this Friday. So you only have a couple of days. So hurry up and submit your topics so that we can set up a schedule for the conference and so on. So that's great.
And may I throw in a few things, Alan?
Yes, please go ahead.
He and I had a good chat yesterday. The contracts are all out. I've put a hotel on the wiki that is rather affordable and a few people will be at already. You are very much welcome to attend the user conference portions. It will be more of a workshop format, a bit of a hybrid, and it should be a lot of fun.
Anything else for the conference?
If there are questions from people above all, because people have been pretty silent, there have been like 6 or so registrations, but I know this demographic is not the most upfront on schedules. And we talk about it every week on Wednesdays at 1 p.m. Pacific, the same slot with the production user group. So you're welcome to drop in and share your ideas and see what we've been coming up with. I do hope to find a foodie, someone who can spend quite a bit of time making home cooked meals because we would only have their cost plus the cost of food as opposed to hotel rates. So I think it should be a rather fun, intimate event. As they always
Michael,
Yes.
in the past, we had the user conference, I think Data had sponsored, and developers came and presented there. Is the user portion just users talking about user things, or would developers be encouraged to come and talk?
You're very encouraged to talk. There is much overlap, and these are rather advanced users. It's not like what is OpenZFS. It is production users. Maybe check out a recording from the production user calls there on YouTube at Call for Testing.
Okay.
And we hope to have an elegant segue from highly refined ideas, some of which I'm happy to touch on here that have emerged, and hand them to developers and say, okay, here's what we observe. We want to hear the technical view on them, and ideally find various people who are willing to perhaps sponsor work like that. So I think this will be rather hands-on. Other questions? And thank you, Digital Glue and IX Systems and FreeBSD Foundation and Delphix, or whatever name they'll be using at the time of the event, for sponsoring the event so far. If your employer wants to sponsor, just drop me a line, or Matt or Karen, and we'll go from there.
Tony, I see Brian's not here. Do you have any updates on the 2.3 release cycle?
No updates. We've just been trying to test direct.io and running into some bugs with that are getting fixed.
Okay.
So no big updates.
Is that the last kind of big thing?
I think so.
I started another run through the direct.io patch, and I just left a few comments, but I'm still reading. But at least one looks like serious, and maybe a leak on FreeBSD. But I do hope it to happen sooner, since we plan to have TrueNAS RC1 release practically tomorrow, and without release branch, it's not very nice.
Anyone else have anything else on 2.3 and related things?
Tony, you had pinged me on one of the tests failing. Did you ever get a resolution on that?
For direct.io?
No, for there was a RAID Z expansion test that failed during. Oh no, sorry, that's not related to 2.3. That's related to the UEMU. Sorry, got my things confused. We can talk offline on that.
Okay.
Okay. Then Don, I guess you want to talk more about the Arc async teardown?
Yeah, Georgia, kind of asked if we were going to consider sort of prioritizing, and we're tearing down IOs or tearing down buffers. Should we prioritize the ones that we're tearing down rather than cannibalizing, existing spas? And so I made an effort at that, and thanks, Alexander, for looking at that. In hindsight, as he noted, it's like, it makes the code more complex. The way I did it, basically, we had a list of the spas that we're actively working on, or actively, background flushing, and so I used that in the eviction thread to, if it had started after those flushes, to only focus on those. But I think it makes the code, more unreadable. So the other approach I was contemplating was, since we know people are actively churning on the evicting because of the background flushes, then maybe we should just back off on the main eviction thread and let those guys do the work. And when they're done, go ahead and resume doing flushes on the remaining pools. Any thoughts on that? Or, I mean, this is somewhat separate from the fix, because today, even when you do inline flushes, they're not prioritized over the eviction thread. So this just puts them in the background. So, but we have an opportunity here, I think, to try to focus, the eviction to the surviving pools.
I think using main thread for that could be interesting, but it may slightly complicate patches that are also now in review for parallel eviction. So from one side, we need to evict certain amount. From other side, we need to evict set of pools. And if it will be all done by same thread, I wonder if it will be too complicated. But if not, I guess it would be nicer from point of CPU utilization and not stomping on each other's foot.
Yeah, the way we use the multi-list and they use random numbers, so they're not always working on the same stuff. So the collisions are kind of minimal, but you're basically using CPU cycles. And if you had a lot of pools, it's like needlessly having a bunch of threads could be nice not to have. One option is I could go to sort of commit it as is, and then after, or if whoever lands first, the eviction thread cleanups, that we could make a post sort of effort to make it simpler. But
well,
main goal here,
maybe we can just rebase the pull request for parallel eviction on top of your change, so that it's all together.
Well, that's true. We could do it as one shot. Okay.
Yeah. Sad again that GitHub doesn't let you base pull requests on other branches than master. So that it'd be easy for the review to be more clear that this is the parallel eviction part, and it's just will be merged after the async eviction, but that might be a way to do it.
Okay. I'll take a look at it and see what the overlap is.
Okay. So that kind of segues into that next thing. So that was parallel arc eviction. We talked about it a couple months ago, and we have a pull request now. Basically, the idea is that, especially with NVMe, where the incoming read and write workloads might be many gigabytes per second, you can end up bottlenecked on the arc evict thread, which was single threaded before this change, actually evicting stuff to make enough room in the arc to continue reading or make the writes or whatever. And so what we did was break it out so that we can, we know how much we want to try to evict from the arc at the moment, split that up across a bunch of threads, and have multiple threads working on basically a different sublist of the arc each. We got some early feedback from Alexander Moten, and we're looking at changing the default tuning. Mav, do you think like 1/8 of the number of CPUs with a minimum of 2 and a maximum of 16 or something makes sense instead of what we had?
I think right now it's half of CPUs, so half definitely overkill. 1/8 should be okay, but maybe some 1/4 in the middle, hard to say.
Okay. Yeah, it's some of the test machines we had 256 and 512 cores. So I don't know if we want to try to do something even more complicated, but in most of the cases we were only thought about the maximum, making sure there weren't more than 16, because having 200 archivic threads didn't make sense. But yeah, we didn't consider the small machines enough, and I think going to a smaller number and just having a floor of 2 or 3 archivic threads would make sure that we don't run into trouble.
One thought about threads I haven't mentioned in any of contexts, but right now we have one evict thread. It clearly can be seen in top, and it's easy to monitor it. If now that one thread will spin and wait for a bunch of other taskew threads, will it be properly visible, and whether bottlenecks could be seen?
With our version in top, you see multiple just arc_evics using up CPU.
So they're properly labeled. I just I don't remember how threads are forked in taskews.
But yes, in our testing, the arc_evict thread shows up. There's like 4 of them each chewing through the CPU as it's trying to evict stuff to keep up with the multiple NVMe drives. And then the second pull request that's kind of related is basically applying the same thing to the debuff cache eviction. Although there's also a bigger change there where, as we talked about a couple of months ago, what it was doing for debuff arc eviction or debuff cache eviction was it would start at the end of the list and walk forward, doing a try lock on each object until it found one it could evict, and then it would evict it, and then it would return to the outer loop to see if it had evicted enough yet, and if not, go back in and start at the bottom of the list and walk up again. And that was, you know, terribly inefficient and mostly meant you walked over the same block buffers over and over and over again. And so we changed it a bit so that we would do it in a slightly larger batch, basically try to evict, you know, 100 things out of any particular list at a time. And so we'll use a lot less CPU to do the same amount of eviction and be able to spread that load out. The debuff cache wasn't as big of a bottleneck because the reader or writer thread that was trying to do stuff would basically get responsible for evicting one thing out of the debuff cache in order to make enough room to make progress. And so that would kind of make it multi-threaded, but only during kind of the pressure scenarios, and it would slow down the actual workload. So by having, you know, more than one of the dedicated threads, it actually is able to, you know, keep up with its high and low watermarks and not get so behind that it has to fall back to the mechanism where every reader or writer is doing some eviction for us. And, you know, probably making it harder to determine where all that CPU time is going in the first place.
I also left my comments over there. I don't
Yes.
have anything else, but it would be nice if those would be answered.
Yep, we were working on that. So thank you for the quick review. It is very helpful. Next, Don, you want to talk about the Z fault diagnosis?
Yeah, so Z has a diagnostics engine built into it, and it'll look at errors coming in from a drive, and its context is only that drive. And if it gets too many errors, it'll attempt to fault the drive. When it sends the fault to the kernel will only allow you to fault up to parity's worth of drives. You know, it ensures that you're not going to lose access to your data, basically. But my first question is, if you don't have any spares, what's the purpose of faulting a drive? I mean, is it just to take it out of service? I'm not sure why we historically do that. Mark, I don't know if you have any insight on that, but
I think partially it was if in a parity situation, if the drive is failing, you might be more efficient to access the parity than it is to actually access the data to reconstruct, so that you avoid a drive that's like very slow, that's failing in that sense. So it could speed up the entire performance of the pool that way potentially. We did the theory.
Yeah, we had done a similar effort with a slow drive where it's not throwing errors, but it's very slow. Okay, yeah, that helps. What happens? What we came across is a situation where somebody disturbed a whole bunch of disks from the whole group, and they all were getting errors, and so it would fault all the up to the parity. So in this case, RAID Z, 3 drives got faulted, and then there was another drive that was resilvering, but because the other drive was in the replacement pair, it faulted that. So you actually had 4 drives faulted, but technically only 3. But it's like in those scenarios, I'm thinking, wouldn't it be better served if when your peers, like in a RAID Z group, are all getting errors, then don't diagnose a fault, because I don't think it makes sense to take 3 drives out of my group of drives. What is it helping? It's like if they're all failing, it seems like we should just back off and say no. We could degrade it perhaps, but it seems like faulting is not appropriate when all the drives are getting errors.
I agree. In fact, I think even the scenario I described, where you have just a single drive which is legitimately maybe failing in some fashion, I think faulting is too far. You should definitely just degrade, because in theory you should still get the performance characteristics, because we'll avoid degraded drives in general. So I agree, though. I've noticed that in the past that I think we are too aggressive with faulting drives, and it's not clear to me where that plays an advantage and where it doesn't. But your example is a good example where it is something potentially above the drive that's failing, and so you're getting lots of faults, and so it makes no sense to fault a bunch of drives because a channel, a controller is going bad. Or something.
Yeah. It's like, it doesn't, I mean, it's like everything's bad. So it doesn't make sense to differentiate, 2 or 3, some parities worth of disk. It's like, they're all bad. Like, don't,
Agreed.
highlight
Agreed.
those guys. Yeah. So I've done that for the slow drives. And so I think I'll try to generalize that mechanism, basically having the contract. You can't diagnose a fault when you have multiples in that same group, in the same parent, under the parent, I guess. Some type of logic like that. Okay.
Now, in the presence of a spare, that there's a different calculus you have to do, of course. But even so, I think that's...
But even so, if all disaggregating errors, it doesn't even make sense to spare one of them out, because I think the admin needs to get involved when all the disks are failing.
Yeah, you're probably correct.
Okay.
Yeah, and that was in particular a concern Alexander had with when we did slow I/O the first time, is if we're getting slows from a bunch of drives because of something that's maybe not specific to a drive, that we don't go and fire up every spare and make the situation much worse. And I think we're basically seeing the same thing here with errors causing us to fault drives. If a lot of drives are all faulting at once, then we're better off not taking action than trying to be helpful.
Right.
Yeah. Just making the diagnosis more aware, not just focus on a single drive. Yeah, the other one I was contemplating was, right now we just have sort of the upper 10 errors in 10 minutes. But if you get a bazillion errors, in less than a millisecond, should we diagnose that as a fault, or should there be some minimum time? Because if someone bumps a cable, you don't want to be just faulting all your disk. It's so that I'm wondering if people have thoughts on that, about having a sort of a minimum threshold in addition to the long.
You mean, so if we get a burst of errors, but then it calms again?
Yeah, some transient burst. Somebody just bumped the cable, and then we get a bunch of errors, but then it doesn't have a lifetime. It's a quick. And in that case, maybe it's not appropriate to diagnose that as a fault.
Yeah, that seems reasonable as well. Yeah, I think
we've encountered that one, right? in some of our scenarios, but.
And a lot of this dates from the days, when in Solaris, where we had the fault infrastructure around a lot of us that was very good at diagnosing things. But I think the heuristics we have in Z simplify a lot of concepts, and yeah, they could definitely help to have some more intelligence in there. So
yeah, and then we can I always envision smart data and other things contributing to the diagnosis, right? It's
agreed.
It's we're just too narrow. It's I got 10 errors in 10 minutes. Okay, boom. I'm just gonna fault you.
Heuristic is just too simple.
Yeah. Okay, thanks.
Yeah, I wonder, almost to that point, if it'd be possible to be able to get the errors from the controller itself and so on. Does the SAS controller driver throw some errors that we could see and be like, oh, well, this is a transport problem, and so don't assume it's actually the disks that are all the problems in this window?
Yeah, absolutely. I mean, if you had the ability to actually probe out the system to that degree and isolate where the fault is actually occurring, then that would obviously give you a much better heuristics out of it. But yeah, it's a hard problem. But yeah, I think anything we can do to improve Zed's heuristics is going to be a win.
Yeah, we could generate, events that it can consume or whatever, but yeah, right now it's so simple. All it consumes is ZFS sort of events, like errors coming in and then a disk coming in. So it's pretty simplistic.
Yeah, exactly. And as you've mentioned, I think that often Zed will end up doing the wrong thing, and so it hurts us rather than helps us.
Yeah, faulting start faulting all your drives. It's no, that's not helping, because now they have less. There's less redundancy now, and that's more opportunity for a catastrophic failure.
Yep.
I think next item on the agenda was the ztest with multiple pools.
Oh, it's get the lucky number this today. Yeah, so a lot of vendors, you know, actually in a lot of cases now we have a ZFS root pool, and so we're using multiple pools with ZFS, but the ztest itself was only ever testing with a single pool. So you know that sort of cross section of Arc and you know now we have asynchronous pull import, you know, all these things. We're not testing any of that in the ztest framework. So before I knew how complicated it was, I took on the challenge of adding multiple support. And so I opened a draft pull request. It's pretty close. And I found a few issues already with that. So I'm thinking that this would be good. I think in general, we would just leave it at one pull for now, but it gives us the ability to, you know, kind of really stress it out. It's like, you know, it's like, and one thing I found right away is like, we don't check for disk space or anything like that. So if you oversubscribe, which is pretty easy to do when you're doing these file-based VDEVs, you know, it dies in weird ways because, you know, it's trying to do an IO. It's like no space left. And in the context it's doing it, it's like, it doesn't ever report that. So you get these weird errors of failures, and then you don't think to look at the obvious solution. It's like, I ran out of disk space. So I added some checks in there. So like right now, if you say, I want to run ztest with multiple pulls and you put, you know, 1,000, it'll immediately just say like, nope, there's not enough disk space to even make that pull, you know, and do anything meaningful. So anyhow, you can check it out. There's a pull request there, and hoping to, you know, get that going sooner than later. Any questions on that?
No, good stuff.
Okay, it's pretty straightforward. I mean, basically all I had to do was, you know, refactor the code so that all the globals, the SPA and all that are now encapsulated in a pool per pool sort of setting. So
Next, add send receive support to ztest.
well, I kind of want to add like Zed and some other things like that, because those interplays are important to test.
Mm-hmm. So next up, just a quick note, the fast dedupe work has now all been merged. So it'd be great if people could play with that a little bit and let us know if they see anything. But yeah, it's all in there now, including the prune stuff. So dedupe should actually work, you know, reasonably well now. And, you know, you can limit the size of the DDT. And with the prune stuff Don did, means that when you hit that limit, it will optionally evict the least useful stuff from the DDT in order to allow you to keep getting the advantage of dedupe without having to have an unbounded amount of memory or flash to store the dedupe table.
That's great. Just to note, we're gonna include that into upcoming TrueNAS 24.10. It's actually merged this morning, latest state of master. That's why we're now waiting for 2.3 branch, but one way or another, dedupe will be in TrueNAS. We traditionally put the big and scary warning, since it's new and tested code, but otherwise, those who want to experiment are welcome. Also, Martin merged that update into FreeBSD master, so anybody using that will see it too. Hopefully,
yeah, I saw Martin merged that this morning as well. So yeah, it's available in FreeBSD master now as well, or main. Next up, Tony's posted a PR to start to improve the SPA namespace lock situation, making a light version of the SPA namespace lock that's, you know, for when all you actually care about is the name of the pool translation stuff, not everything else that the SPA namespace lock has come to mean. Tony, do you have anything to share about that?
Yeah, so just a quick overview. One of the problems that we've had for years is you'd have one of your pools die in some weird way while holding the SPA namespace lock, and then you couldn't run zpool status to figure out why it died. and you
Or
run people
ZFS
through it.
list or anything.
Yeah, or anything, and it would just lock up your command, and that's really annoying. And it comes down to the spot namespace lock. The spot namespace lock was originally designed to protect the AVL tree that holds all of the pool name to spot T mappings. So normally you take the lock, you'd look up tank, and then it would give you the spot T for tank. But then over the years, people have used the spot namespace lock for other protections, like the meaning of which has been kind of lost to time. So yeah, my PR introduces a new lock that's like a lightweight version of that. That just locks up the AVL tree. That's all it does, and then changes the zpool status code path to use that new light lock. So I'm still testing it, but I'm cautiously optimistic.
Okay, Tony, the important question, what did you name the lock?
It's called spot namespace light lock.
Oh, oh, I don't know.
So anyway, when I'm feeling better about it, I'll take it out of work in progress status and people can look at it.
Sure.
Yeah, thanks for taking that on, Tony. I have another patch that we never opened up, but it lets you steal the lock. It's like, because the guy that holds it is gone, you know, so he's not going to be doing any work, but I think this approach is better.
Well, I think, Don, yours is probably still necessary if you're doing anything else that's protected by the bigger lock.
But yeah, the non-light version of it. Yeah, that's true.
Yeah, because nothing worse than not being able to, list or make a config change or anything to pool B because pool A went out to lunch on you. It's really been the biggest problem with the work we're doing on forced export is that we can't, get the namespace lock in order to remove the pool from the namespace because whatever else is holding onto it. And, we try to interrupt most of those things, but depending where it's stuck, that might be easier said than done. Okay, next, Rob, did you want to talk a little bit about the ZIO flush changes to propagate ZIL errors?
I can. Was there a question?
No,
Or
just to kind of give an
macro
overview
about
for
it?
everybody.
Yeah, right. So sorry, that one's been out a little while. The basic gist of that PR is that so throughout ZFS when you call ZO flush, you get a flush, but nothing actually checks whether that flush succeeded or not. And that's sort of everywhere.
Yeah,
And
like that dates back to the
the
earliest public versions
beginning.
of ZFS.
Yeah.
And mostly seems to be some drives didn't return like E not supported. They just returned an error every time you tried to flush. It's like, I don't know what hardware doesn't support flush, but it's not common. But it meant that ZFS just ignored the error. So if you did a flush and you got back an error, you're like, okay, the flush succeeded. Let's, move on and make the next transaction group or whatever. And that in, situations where, like Mark was saying, the controller goes crazy or something, means that you do a flush and you think it succeeded, but the writes never made it to disk. And then ZFS's kind of in-memory state about what the state of the pool is wrong. And then things go downhill very rapidly after that.
Yeah. So so that's been something we've been working on for looking into. We had a customer where exactly this happened quite a few times. So we've been looking over that for the last 2 years. And finally starting to get those patches out. So this ZIL patch in particular applies that to just the ZIL at this point. As in what it does, it couples the flushes and the writes together so that in a way that effectively the ZIL write doesn't appear to succeed, and thus fsync returns correctly until that corresponding flush has also succeeded, like actually checking the error there. So so that particular PR works, but it has a downside, which is that when we issue a flush, when we call ZO flush, that's called on the top VDev, not the actual individual devices. So like, it's called on the RAID Z group or the mirror or whatever, and all the individual devices underneath it get a flush. And of course, ZO groups being what they are, if one of those fails, the entire thing appears to fail. So what that means is if you have a drive degraded, then and you call that flush, the flush will fail because the drive isn't there, because all it does is just send it to all of them. And for the ZIL, that means it will go, oh, the ZIL write failed. I will fall back to just a regular transaction sync. And so you end up with a performance degrades on fsync, if like your pool is resilvering or you're swapping a drive or whatever, which also sucks. So that's why that particular PR is in draft, because there is another PR following it that adds what we called a VDev trace, which is, it's a bit like the ZIL internally has a thing where it keeps a list of all the VDevs that it wrote to, and then it kind of, if nothing is interested in this ZIL commit, it will delay the flush. It will basically move that tree of VDevs on to the next time it's called and flush those there as well. Flush those there instead of now, so we don't end up flushing more than we need to. So it takes that so this PR takes that concept and builds that into like the ZO tree itself. When you specify a particular flag, we keep a little tree of all the leaf VDevs that we actually wrote to service the write, and then the caller can take that and issue the flush to only those devices, and in that way we can bind the write and the flush together. You don't end up flushing devices that might not be there that you never wrote to, so you don't have to deal with the problem, but you do make sure that you get the whole lot. So that's fine. But then, and that works. But that's in draft, because then I started looking at, all right, well, what are all the other places we do flushes that we should have that hooked up? And it turns out that binding a write and a flush together from the outside, from the ZO call site, so say in like VDev sync uber block, for example, is actually really, really difficult to control from the outside. And so it's very difficult to hook that particular mechanism, which was kind of designed around the ZIL idea, through everywhere. So I have another take on that now, which I haven't pushed yet because it's not finished, which is bring that all inside the ZO pipeline. So you do a write and you add to your write ZO flag flush write, I think it's called, and that will arrange that write ZO at the top level will not succeed until all the corresponding VDevs, leaf VDevs, have received a flush. But it's got some stuff in there to, like, if I've got multiple writes in flight for the same VDev and they're the same like root of the tree, then actually delay the flushes at the end till later. Otherwise we end up with just like, a scuzzy FUA kind of flush, which is just every time, and then that's slow. So anyway, the point of all that is, it's hard to do, and we're working on that, and that's why those two PRs are in draft. But yeah, I don't have much else to add, but you should ask questions and give me a show things. Sorry, Alan, I kind of, that's why I asked you the question. I'm like, oh, I can talk about this stuff, but yeah.
Rob, do you have a notion of when you might have the problem solved?
Not not exactly. Like, I think I know exactly what the problem is. It's just finding the right way to build that into ZFS, such that it can be comfortable to use and work in all the places we call flush. I think the end game just becomes you almost never do a flush directly, just anywhere you call a write. Like, it might be that all writes end up being flushing writes, and we delay the flushes off to the end, and the magic happens. So, do I know when? I don't know. Someone make 2.3. I'd really love to.
Right.
I'd really love to have this in like have a finalized mechanism in a PR maybe within the next couple of months. I'm working on different projects at the moment, so I've had to put that in the back burner for a little while. But yeah, it's a lot.
Okay, fair enough.
Yeah, the biggest problem with our earlier approach of trying to deal with it once the flush fails is that most of the time the asynchronous writes aren't around anymore at that point. And so we had to resort to the kind of gymnastics Rob is doing now of attaching the flush to the original write ZIOs so that we're not freeing those until the flush has succeeded. So that if it doesn't work, we actually still have the rights to retry. Because in the situation we're seeing at the customer, the controller module in the JBOD goes haywire and has to be reset. And that's resulting in basically the drive resetting. And so some async writes went to the drive. Maybe they got written, maybe they didn't. The controller goes bad, the pool suspends because all the disks went away. And it was just kind of in the middle of a transaction group. So some writes were done, some writes are still about to go out, and then the flush. We resume the pool with the zpool clear after we get the drives back online. We do the second half of the writes, we do a flush. The flush says, yes, everything's great, but actually some of the first set of writes never made it to the disk.
Right.
And then we go to read them back later and it's like, where's the data?
Right. Yep. Makes sense.
Yeah, because the flush in that case succeeds because the drive was power cycled between the writes that actually got lost and the writes we did later. And so it's not lying to us, but it doesn't mean what we think it means.
Yeah, exactly. You didn't flush the data you thought. The data there is, these are not the data. This is not the data you think it is.
Yeah, it kind of almost related to the old Linux Postgres thing where, on Linux, when you did an fsync, if it failed, you did a second fsync and it would succeed and say everything is fine, but it didn't actually flush what you thought it did.
Right.
And as Rich says, imagine how the disk feels. It's like, I just woke up and you're asking me to flush. And I'm like, yeah, I can flush nothing. And it succeeded instantly.
I'm reminded of years ago when I encountered a bug in some disks, which would sometimes drop things from the write cache after they told you they had flushed it. And then suddenly you would go to read it and it would not contain what you thought it did. I was very confused why my RAID Z3s kept scrubbing more errors every time I read them, but they were checksum errors. Thanks, Samsung.
But and then next thing, Pavel, you wanted to talk about your rate limiting PR?
Yes. Can you guys hear me?
Yep.
Okay. Okay. So I get back to implementing suggestions from the review, especially thanks to Alex for some ideas and pushing me harder. So I was able to remove all the memory allocations that this whole idea I had for having slots. It could be removed, so we don't allocate memory anymore. So we can set up really small limits, and it doesn't really matter anymore. It should work. So one of the problem with small limits is that it wasn't possible to interrupt operations. So for example, if we set limit to like 1 kilobyte, and we try to read 1 megabyte, normally ZFS doesn't interrupt the loop for reading or writing. So sometimes it's tricky to interrupt those, and we can now interrupt in the middle of the operation. So we will get a short read or a short write, and this is up to applications to handle this properly. But at least we have a way to stop system call, because for example, in this case, when we have 1 kilobyte limit and we read 1 megabyte, it can take a long time to finish, and even administrator wouldn't be able to stop this. But interrupting is sometimes tricky. For example, one hard case was read dir, and reading content of the directory I treat as reading the data, because this is the only metadata operation that can generate a lot of disk traffic. All the other metadata operations are just simple single block updates or reads. But we don't know how much data will be read before we finish, because we iterate over directory and we add new entries, and then at the end we know how much we should charge the process, which is a bit too late because we really want to charge upfront, because I can imagine somebody trying to abuse and just fork and issue read dir calls. So what I do now is I try to charge for one block of data upfront. So if there is like a huge queue already and a long wait, the process will need to wait to even start reading directory, and then I charge for the rest at the end once I know how much should I charge for. Another problem was send and receive, because to do that I introduce I'm just using I added delay sig function, which basically is sleep but can be interrupted by a signal. But for send and receive, what send and receive does is it calls ioctl, and this ioctl in the kernel will create additional kernel thread, and we'll use this additional kernel thread to read or send the data to the descriptor. And now if we try to send a signal to this process, to ZFS send or ZFS receive, this sleep is not interrupted. The sleep being in a separate kernel thread is not being interrupted. So I had to introduce additional version of this function, which basically spins and sleeps for a short period of time and checks if there is a signal pending for the whole process. And this allows us to basically interrupt ZFS and send and receive. Also, another change I did was to add a function. This is, for now, it's only for block cloning, but for example, you have a limit on reads and you have a limit on writes. So I didn't want block cloning to be charged for reading first, and one that's done, then charge for writes. So there is now a special function that allows to charge for both at the same time. So if you have like a 1 megabyte limit on reads and 1 megabyte limit on writes, you can clone files at 1 megabyte speed limit, bandwidth limit, and not to have those treated separately. Yes, so those changes are already in the PR, and this is what I was kind of concerned about. People start to comment and have different expectations to this function. So we will see. But some comments are make sense, like using arc. Well, if we should allow applications not to be charged for ARC usage if they don't have to read from the disk, which makes sense, although I think it will be much harder to implement because we have to go much deeper into DMU to be able to tell if the data is actually cached or not.
And I think kind of to your point in the PR that it's much more predictable to make it based on the logical data rather than whether or not it was in the cache, or if it was compressed, then it charges you less, and so on and so on. I think from an administrative perspective, while I can see the point of, maybe not charging for the ARC, it just makes it so unpredictable, and it's not something the user has control over in the end, right?
Yeah. And for me, it makes more sense to be predictable, but also I'm biased because this is also easier to implement than to go somewhere deep and check if the data is cached. I don't know, but I can, even if you have like multiple containers, I could still see one container trashing the ARC all the time, and other containers still having to need to go to the disk. So you don't really have this equality in usage of the ARC. So I think it's also good to slow down the container that is trashing the ARC and let the other containers to use the ARC as well at their pace. So I don't know, but maybe we need some exceptions at some point. And one last comment, not related to Ratelimits, but somebody was asking about send and receive in ztest. So actually I have a branch which already compiles, where I was able to move much more stuff to userland, including ZFS ioctl, ZFS VFS ops, and some other files. So actually diff is extremely large, because what I was trying to do is to find files that are very similar between Linux and FreeBSD and make those not OS specific, but generic. And but this is combined with all the other changes, so it makes a huge mess. I want to create a like clean PR where I make the changes to those files, like to FreeBSD and Linux files, to make them identical, so people can review those changes easily, and then another commit would simply move the file to module ZFS.
Yeah, I think that'll be much easier to review that way.
Yeah, and also this change is starting to treat userland as just another platform next to FreeBSD and Linux, and not something special. So
yeah, I was going to say, Rob just pointed to one of his pull requests. He's been working on something that sounds almost the same. So yeah, you should just maybe sync up.
Definitely.
On the rate limit thing.
Whoever
on the rate limit thing,
have less collisions to deal with.
Mark, did you have something you wanted to add on the rate limit thing? I saw you. Looks like you had something to say.
No, I'm good. I was just gonna add some color comment, but it's it's good stuff.
Okay. Because I saw that one other request in there is something I'm interested in, but I think would be, an add-on we could do after, is, the kind of the idea of a, rather than a rate limit, like a reservation, where you say, this data set gets guaranteed up to this many megabits or megabytes or IOPS, and then everybody else can use what's left over, kind of thing. In general, that's not exactly doable. It's more just that data set would get priority before others to get its IO done. I don't know how practical that is, but I definitely wouldn't want to hold up the rate limit stuff to do it. But do others have thoughts on if that would be useful?
It seems like something people think they would want, but in practice would be too much of a nightmare to maintain for it to solve more than most trivial cases, I think. Right, because you don't exactly have control over how many operations you're going to get out of your storage. It's a really complicated question. So
yeah, so like if you have kind of the case there of a bunch of containers or whatever, of so if you have 5 containers and you're going to reserve each 100 megabytes a second, and you have enough bandwidth to support that, then that makes sense. But yeah, like when you don't, or you start getting over provisioning, then what does the reservation mean, and when do the non-reserved operations ever get to happen? Right? You can't just be like, oh, a container with a reservation is using 100% of our capacity, and so all the other IO just never happens. That doesn't make sense either, right?
yeah, like it also gets messy whenever it gets into something with global state, like how many transaction group syncs are you allowed to trigger from a container, and then block everyone else.
Right. Well, the way Pavel did it, there's not a global per se. It's kind of just hierarchical, but yeah.
But it would be like, I think, super hard if we could simplify it to what you are saying, to just checking if there are any processes waiting for just sleeping because the limits are reached, and basically, if this is the case, then you have to wait before everyone else is satisfied, basically. But of course, you would still want to somehow bump the priority to not starve those processes forever.
Yeah. How do you come up with something that allows forward progress while still respecting the reservations? Yeah. That was it for the agenda. Was there anything else anybody wanted to talk about?
I did want to ask if anyone had any thoughts on something that came to mind that I think talked about with you, Alan, before, but it came to mind when you were talking about the parallel arc eviction and DBUF eviction work. I had been thinking about, for ZIO compression threads, whether it might make sense for us to sometimes limit them to less than possibly all of the write threads that we allow, because we have things like LZ4 where it's not really going to matter that much if you schedule like one of them on each logical execution thread. And then we have things like zstandard 19 where you really shouldn't schedule that on 256 cores at once. Nothing good will happen.
The default is 70 or 75% of the CPU cores get a ZIO task queue.
Yes.
And you're
I
saying
believe
just
that's
having
true.
a separate limit for compression specifically?
I was wondering if anyone had done any experimenting or thinking about having possibly something for what I might describe as more heavyweight things, right? Like, because running, say, LZ4 on 2 hyperthreads on the same core is probably okay. It's not that expensive. Running zstandard 19 on both your hyperthreads, I'm going to bet that you're going to bottleneck on not being able to satisfy both threads at once. Right, and gzip is kind of expensive all the time. So unless you have hardware offload. But so I was wondering if anyone had played with adjusting those numbers, or possibly specially handling the more expensive options differently, because obviously it matters. It is a very different experience for running some of these versus the others in terms of when you are going to consume all your system's resources.
No, I'd like to mention first that now on our large systems, we won't be able to use all CPU cores for single written file. It will split task queues between different allocation threads, issue threads, sync threads, sorry. and so you will be limited by less number of cores. But it was not exactly from the perspective you mentioned. That the idea is to reduce lock contention and handle more IOPS per second on large systems. While what's about using compression on cores, that's difficult to say what is right. We had some significant problems doing benchmarks of heavy workloads when in some situation we get some sort of performance inversion. As soon as we get all CPU cores busy, something happens and system performance drops lower than it was before. And I'm not exactly sure about the cause of it. I'm sorry, somebody has echo. It's difficult. So I'm not exactly sure what goes on there and how to address it, but I would definitely like to understand what to do if somebody has good ideas or somebody working in that area. So I had some thoughts, maybe I get out of CPU caches at some point that dramatically drops memory bandwidth and has cumulative effects. But so far I haven't got to anything productive, but that's still on my plate. And I would really like to investigate. But we saw that even with LZ4, not even speaking about zstd or gzip. So yeah, I tend more to blame caches rather than CPU instruction per second or whatever.
That makes sense. Yeah, mostly I was specifically thinking about having encountered a number of users who assume that zstandard 19 being a setting that exists means that it will work perfectly fine if they set that on their data. And then they discover they're incorrect because the CPU and particularly memory usage scales non-linearly as the number goes up. And then they're like, where'd all my RAM go? Why is my system running and like not doing anything? Oh.
Yeah, I haven't played with zstd much, but from a quick look on LZ4, I have a strong wish. I don't know if it's possible or not, but implement a specific version of LZ4 that doesn't write output buffer, but just goes through the input stream and tries to detect whether it's compressible or not. That would allow to make more efficient algorithm of bypassing zstd for uncompressible data. Because right now we're just waiting memory bandwidth by writing the things that we will never use, and after that we bypass zstd and drop the data. So it would be nice to implement that too, but I haven't got to looking on that yet.
Yeah,
and that partially would solve problem of zstd 19.
Yeah, and there's still the one in the back of our head is, well, can we teach LZ4 and zstandard to be able to consume an ABD, a scatter buffer, instead of having to, copy it into a linear buffer first before we try to compress it or decompress it.
Yeah, that would be good too.
Like zstandard has a streaming mode, but I think it changes the on-disk format, and so yeah, when looking at other options, might have to be able to kind of compress a bit at a time that way.
Yeah, I don't think teaching LZ4 to consume ABDs would be too bad. It doesn't, I think, that much inherently care about anything more than the window it's operating on. zstandard, I think you could, but it would be harder because the windows get bigger. In terms of operating purely in place, that would be messy, and I would just replace LZ4 with something that like calculates the Shannon entropy or something. If you're looking at replacing that early abort functionality, but that gets kind of messy because it turns out that there's not really a purely great detector for whether something's going to compress other than trying.
Well, I think what Alexander was proposing was, can we get the LZ4 test by trying to compress it, but just not writing an output buffer, just keeping track of how much space it would have needed?
maybe I need to go look at the code again, but I think it uses the on. I think it may use some of the state that it writes out to go reference later. So you would need to refactor it to keep that somewhere, but maybe I'll go look again. But yeah, zstandard changes the on-disk format if you use the streaming or multi-threaded modes. So you could do it, but and like that might be necessary if you really do want to use the ABD mode, or if you really wanted to consume ABDs. That might be beneficial enough, but I guess it depends on what your use case is, other than just for sanity. But
in general, the use case for the ABD there is just to avoid the extra memory copies.
yeah, that makes sense. I don't think it has a clever. I'll think about it more, but maybe some of this. No, that probably not. I was gonna say maybe the newer zstandard having more hooks for hardware offloading might be helpful, but no, I think that just lobs a huge buffer off and says deal with it. So I don't think that saves us, even if we did that. But yeah, I was just thinking because it seemed like we should probably treat the different kinds of compression differently, because they are able to consume much different patterns of resources. And consuming 3/4 of your threads or CPU cores with that. Actually, it's worse than that, isn't it? Because we have 3/4 of the cores for high priority and low and normal priority threads, isn't it? Right, because we have the two different types of write task queues.
Right, but the compression is done in a different task queue, isn't it?
No, I think
compression
it's
is
done
done in
inline in
normal
the
write,
right.
but I actually exit out high priority threads. We have only one set and use high priority like higher priority input.
That makes sense. But yeah, no, there was a paper that showed nice gains from putting the compression in a separate task queue in some ways. But no, currently it's just inline in the right task queue thread. Which could be beneficial to not do, but that's neither here nor there.
What else would you give that CPU time with higher priority if it's already dedicated right thread, right task queue?
Specifically, I think the goal would be something like I was describing about hoping to limit the compression performance or the amount of resources you're consuming with your compression separately from how much you're going to do with writes in general. Right.
I guess it depends on the use case, because all your writes are going to be bottlenecked on the compression generally, right?
Maybe it depends on how you did this, right? Like if you had something like expensive and cheap compression task queues, for example, you could see servicing that differently. And then since all the metadata is currently compressed with LZ4, they're only going to go through the cheap threads.
But anyway, to commit transaction group, you would need to complete all of them. So it may not save much unless you have, actually right now several pools have several different task queues. So they won't even collide outside of CPU scheduler.
Yeah.
And for one pool, prioritizing doesn't make much sense. It doesn't matter in what order they process it. It has to be all processed.
Yeah, that brings up an old thing I need to get back to of changing the way we calculate the number of task queues so that when you have 7 pools, you don't have all 7 of them each allocating 70% of your cores for their task queues.
Yes.
Yeah, maybe they has to be global somehow, but we need to decide who manages them.
Yeah, because it's not easy to change the number after so much.
Yes.
Yep.
All right. Well, we're over time anyway, but thanks for a great meeting, everybody. Our next meeting will be, should be in about 4 weeks. Yeah, so our next meeting will be this same time on October 8th. The meeting after that will be at the earlier time that is not quite as early now. So it'll be 10 a.m. Pacific instead of 9 a.m. So not too much worse for Europe, but a little bit easier for everybody. And so look forward to seeing you all next month, and then hopefully also at the Developer Summit. Thank you, everyone.
Thanks, Alan.